Hello students, in the live class we already have covered the reaction of metal and non-metal with oxygen and water. Now in this video we're going to study the reaction of metal and non-metal with acids. How metal and non-metal reacts with acid and what products they formed. We will study this and later we'll also learn the reactivity series. Okay, so let us start with the reaction of metal with acids. Now see, when metals comes in contact with acid, then they form salt and hydrogen gas is released. Okay, they form salt, they form metallic salt, and there is a release of hydrogen gas. So how this sodium, iron, aluminium, magnesium, these all are metals, students, right? And metal when comes in contact with HCl, HCl is hydrochloric acid. HCl, then it forms sodium chloride, NaCl. It is a metallic salt and hydrogen gas is released. Clear? In the same way, when iron react with hydrochloric acid, then it forms iron chloride, that is salt, and hydrogen gas is released. Aluminium react with hydrochloric acid, it forms aluminium chloride and hydrogen gas is released. So whenever any metals comes in contact with acids, then it forms salt and hydrogen gas. Okay, so metal reacts with acids. Some metal reacts very violently, means vigorously, means it's a very fast reaction and they catches fire also. In some cases, some metals react slowly. It is a slow reaction with metals and there is a slow evolution of hydrogen gas. Okay. So next, when non-metals do not react with dilute acid. Non-metals do not react. Up what happens when the metal reacts with base? Reaction with base. See, with bases only some metal reacts, like aluminium, zinc. They form aluminate, zincate, the name of the salt, and the hydrogen gas is released. But the reaction of non-metals with sodium hydroxide, it is little complex. Okay. Now you will going to study the next step is the displacement reaction. Displacement, as the name says, means replace, to replace something. So the metal which is having higher reactivity, it replaces the another metal with the low reactivity. Okay, see, this is a reactivity series. In this, the metal which are placed above, they are highly reactive metal. Okay, these are highly reactive, these are moderately reactive, and these are least reactive, or you can say some are native also. Native means which occur free state in nature or are called noble metals. So they are categorized into three different groups. It is highly reactive, moderately reactive, and least reactive. So what happens when this calcium comes in contact with the iron sulfate salt? Yes, calcium will displace iron from its salt. Means calcium is more reactive, so it displaces iron from its salt. Right? So the metal with higher reactivity replaces the metal with lower reactivity from its salt solution. So let us come back again. So displacement reaction, it says that arrangement of metal in decreasing order of reactivity is called reactivity series. And the metal which is highly reactive, it displaces less reactive metal from its salt solution. Okay. Next, we're going to see displacement reaction. Again, metal can replace another metal placed below it in reactivity series, but cannot replace a metal placed above it in reactivity series. See how it happens. The metal which is placed above, okay, which is placed above. If you will take the salt of that metal and you will react it with some other metal which is lower in reactivity series, then it will not displaced by that, or you can say no reaction will occur. Let us take the example of iron and copper. Let us see this. See, iron, this is Fe, and copper sulfate solution, this is CuSO4. When they both react, it is blue in color. Copper sulfate solution is blue in color. Then when they both react, then it forms iron sulfate and the copper is displaced because copper is less reactive. Again come to reactivity series. See, let us see copper. Where is copper? Copper is here, below hydrogen. Okay. And where is iron? Iron is above hydrogen, here. Iron is here. Clear? So, iron is more reactive than copper. That is why iron replaces copper from its salt solution and forms its own salt solution, which is greenish in color. Okay, तो blue color से solution will turn into green color, pale green color का solution बन जाएगा. लेकिन अगर आप, if you will place iron sulfate and copper strip in that, then no reaction will occur. Okay, because iron is more reactive and copper is less reactive. So less reactive metal cannot replace most reactive metal from its salt solution. See now, see magnesium and copper sulfate, zinc and copper sulfate. See, magnesium and zinc both are above in the reactivity series. See, here it is magnesium, here it is magnesium, here it is zinc. Okay, they are placed above and copper is placed below. So they both replace copper from its salt solution, like in this equation. Like copper sulfate solution, it is blue in color. When magnesium metal is dropped into that, then it will displace copper from its solution. So this is the displacement reaction. It happens only with the reactivity of the, it depends upon the reactivity of the metals. Okay. Now one question is, why the hydrogen is placed? Hydrogen is a non-metal. Why it is placed in the reactivity series? The answer of this is, see, the metals which are placed above the hydrogen, they all displace hydrogen from its salt solution. Okay, ये जितने भी ऊपर मेटल प्लेस हैं वो हाइड्रोजन को उसके सोल्यूशन से डिस्प्लेस कर देते हैं, जबकि those who are placed below hydrogen, they cannot displace hydrogen from its salt. Right? तो इस वजह से हाइड्रोजन से ऊपर वो वाले प्लेस्ड हैं जो हाइड्रोजन को उसके सॉल्यूशन से बाहर निकाल देते हैं, और जो नीचे प्लेस्ड हैं दे कैन नॉट डिस्प्लेस हाइड्रोजन. दैट इज व्हाई हाइड्रोजन से कंपेयर किया जाता है, बिकॉज ऑल एसिड्स comprises of hydrogen, like H2SO4, HCl, ये सारे एसिड्स में हाइड्रोजन होता है. So when they displace hydrogen from their dilute acids, then they are placed above. I think it is clear to you. So this ends, the chapter is end now, it's come to an end. So if you have any doubt, you can ask in the live session. So today we have done reaction with acids and the reactivity series. Hope you will learn it and you will try the questions which are given in your textbook. So thank you, students.